So I'm going to do question 6 on the circle page. Okay. So on this one you have there was a large circle. I'll draw that bigger.
Projector is not working.
Oh, because it's not on. Well, I'm drawing it so you can see it now in a second when it pops up on the screen. Oh, it's recording. So you all will become clear shortly. You're going to see a beautiful picture now in a minute.
Are you sure about that?
Oh yes, don't you worry. Don't tell me the projector's not working. What's wrong with this projector now?
You know, this time they will let us realize the gesture.
No. There's a cable hanging out the back. See the red, white and yellow cable? No, the projector.
Yeah.
Is that normally plugged in?
Yeah.
It's always hanging out, is it?
Yeah.
Something's wrong with the cable. It must have fallen out. Oh. Did I fix it? Or is it worse?
It was working.
Huh?
It was working like.
Well, why didn't you say anything? You just let me off. It was working. Oh my goodness, guys. Killing me. No, wait, it's not working. Did you see my screen?
No.
No.
It does not work.
I think the cable fell out. What the heck? Ah. Guess it did fall out. Hang on. Yes. And it's not plugged in either. because there's no power on it. Let's see what happens. Alright, here we go, the big one. I have it here. No, I know, but it's better than a minute ago. So that's the wrong one. It's not this one either.
Look at the keys of this.
Hang on, there's nope. Well, this is the last one. Oh dear. Woohoo! That was hard work. I know. It's because I just unplugged it. Right. Right. It'll come back, don't worry. There we go. So there's my beautiful picture, but a circular one. So what's happening here is the red ball is rolling down on the black ball. So let's just... It's the last one on the circular motion. So I'm going to call this angle here theta. So if you look here, there's a weight acting down, which I'll call mg. Okay, and this mg has a part going this way and a part going this way. If this is theta let me see now, then that means this angle here is theta, because it's this from maths, you know, if this is theta, then this is theta.
Yeah.
So if that's theta, that means this one here is theta, which makes this one here the mg cos theta, and this one here the mg sine theta. And there's also a reaction force here of or. So if I was to look at the ball, there's a force this way called or, a force this way called mg cos theta, and a force this way mg sine theta.
Cost looks lost. The cost looks lost.
It's okay. You know what it is. So, this is moving in a circle. I just realised the video was recording as I was trying to fix the projector. So if you watch this later, there'll be 5 minutes of me going, come on, stupid cables. So, this one here is going in, and this one here is going out. These two together is like this. I'll put it here again in red. This one is going in with mg cos theta minus or, and this one is going this way with mg sine theta. But I don't really care about that one right now. What I care about is this one, because you'll see I'm doing it. I care about this one because this is the one that's making it turn in a circle. This minus this is what's making it go in a circle. Okay, so this force here is a circular force. So you remember you have a formula F equals ma, and what's the a? It's v squared over or. Remember that formula? Yeah? So that's equal to mg cos theta minus or. So that means mv squared equals mg or cos theta minus or. So that means a half mv squared equals a half mg or cos theta minus or. Yeah, it is, but I actually don't really care about this in a moment. I'll show you why. We want to know when will the ball leave the surface. So what will happen is, when this leaves, what happens to the or? It becomes 0. Why does it become 0? When the ball leaves, when it finally falls off, what happens to the or? It becomes 0. Why? Because there's no what? Not tension, not the word.
Reaction or something.
Yeah, why is there no reaction?
Because it's not acting towards the center.
No. Why is there no reaction?
Because it left the surface.
Because it left the surface. There's no surface to push against. So there's no reaction. So we want to know when it will leave, and it will leave when the or is 0. So that means here, this piece here is 0. So I can forget about it.
So you said in the question
When does it leave? Yeah. Yeah. Now I did some rearrangement on purpose, because what do I have now? What is a half mv squared? Kinetic energy is a half mv squared. So I have kinetic energy is a half mg or cos theta. Now, if I go back up here, when this leaves, it will have kinetic energy and it will have potential energy. At the beginning, what did it have? Only potential. At the beginning, its potential energy was mg, and the h is 2r. Later, it will have kinetic plus potential, and the height, I'll have to draw it here for you, but if I draw my triangle, how big is this side of the triangle here? It will be r cosine. This side? Cos. So it'll be r cos theta plus r. That's the height here. So you can have the potential energy at the start equals the potential energy plus the kinetic energy at the end. The potential energy at the start was mgh, and the potential energy at the end is mgh, which is r plus r cos theta, plus kinetic energy. Now I have this special formula for kinetic energy I just worked out. The reason I did that is so I have no v and only cos. So although this looks difficult, you can actually solve it now. There's an m in everything. There's an r in everything. There's a g in everything. So you're left with 2 equals 1 plus cos theta plus a half cos theta. So I have 1 equals 3 over 2 cos theta. So 2 over 3 equals cos theta. So if you take out your calculators, you can get theta is cos inverse 2 over 3.
It's 48.18.
Yeah, now we really should be using radians though. 48.2 degrees. That's the angle when it leaves the surface. So that was a very difficult question. Too difficult for the exam, I think, but good for you to see anyways. Okay, let's go on to the next topics, our next worksheet.
It's moving. It's moving. There's not like potential.
It does. Potential energy only depends on its height.